Alright, welcome to Module 6 Bash and Networking, where I'm just going to talk more about networking stuff and go over some networking commands as well. Um, again, networking is the foundation of cybersecurity. Networking is how everything works, and yeah, if you do pursue cybersecurity like me, you're going to have to do a lot of networking. I did a lot of networking in my first year. Um, did I enjoy it? Kinda. It's okay. But anyway, let's just start by installing the tools that we're going to need for this lab. Okay, so we're going to begin by updating the package list, and then installing the tools that we need. So we will be installing netcat. Now, for you, when you run sudo apt install netcat, it might not work. So just type in netcat traditional. This one works for me. Netcat normally didn't work for me. So if it doesn't, then just try it, typing netcat traditional. We're also going to be installing curl traceroute. And I believe that's all we're going to need. So we're just dash y again. So we just answer all the prompts, so we don't need to worry about it. So we can just install everything and get going. All right. So first thing we are going to be doing is running the ping command. So type in ping-c3 and then google.com as the target. So essentially what ping is, so ping sends ICMP echo requests. It basically just checks if a host is up and reachable. When I was in my first year, I used a lot of Packet Tracer. You might be familiar with that software, maybe not. But it's basically a virtual environment where you can build networks, and the ping command is what we used a lot to test configurations and to see if there's any where faults are as well. So say you have a network where you have one host and then a router and then another host on the other side. You could try and ping that host as a way of like, can I reach you? And then the other host will send a reply saying it's successful. Dash C3 basically just caps it at 3 pings, because if it's more, well, if it's not specified, if it was just ping google.com, it would go infinitely. So running this, you can see that we're getting replies from the Google DNS. So, and again, in a network, you'd probably be pinging a specific IP address. You can change google.com to be an IP. We can ping ourselves, stuff like that. It's really handy for troubleshooting in general. And yeah, as I said, detecting if a host is up and reachable. The next command we're going to be using is curl -I, capital I, and then type in https example.com. Example.com is an exemplar domain. You're allowed to scan it and stuff like that. It's just used for example purposes. But essentially, what this does is it sends a head request. That means it just asks for errors, headers. Sorry, no page content. So if we were to run curl https example.com, it would just reply with full HTML of the page. However, if you put curl-I, again, we're asking for headers. Headers basically, they contain a specific amount of information, such as the version of protocol it uses, cache control, server time. You can see if we just run it. So if we run that, then it fetches the information, and as you can see, we have the protocol, content type, so it's got HTML, E-tag. Basically, the E-tag is a unique identifier assigned by a web server. Last modified, cache control. Cache refers to the memory, so how long it spends in cache memory, day, and whatever else. So handy for just, so what you're seeing is a header. This is like just basic information about the website. Curl-I extracts that basic information without us having to download the entire page. It's quite useful. Next, we're going to be running traceroute. So traceroute is very useful in networks as well. So we do need to end this because it will go on infinitely. The asterisks basically just mean no response because the ping, well, kind of the ping, because we've already traced the destination of Google and we got it in the first response. The asterisks basically just mean no response because it's already done. So traceroute just shows every hop between your machine and the destination. So as you can see by looking at it, 30 hops, you can see the gateway that you used to get there. Very handy, especially in smaller networks as well. Say you have multiple routers or you're using VLANs, it is great for finding the source of where packets are dropped. So dropping packets refers to when a router or layer 3 switch drops a packet because of numerous reasons. It may not have a destination, your IPs might not be configured correctly, the configuration on the networking device might be incorrect. Traceroute lets you know where the packet was dropped, where the errors are, so it's easier to pinpoint things so that you know what to fix. So next we're going to be using netcat. So type in the command nc, that's short for netcat, dash z, v for verbose mode, and localhost, if I can spell. And then we're going to be just going for ports 22, 80, and 443, same as module 4. And if we run that, it will reply that localhost SSH is open. If you followed with module 5, we opened SSH in module 5. If your SSH is closed and you need to open it and don't know how, go back to module 5 and skip to 7 minutes 40 seconds. It's around there. So what netcat basically does is it does a TCP connection test, transmission control protocol test with each of these ports. The dash Z means basically just scan mode. It doesn't send data, it just checks if the port's open. Dash V is also for verbose mode, so we can output the results. You'll notice that it has only responded with 22. This is because netcat will not really respond unless you specifically tell it to for any errors. So we know 80 and 443, both those ports are closed. I have not opened them. I've only opened SSH, which is why it replies with SSH. The other ones are ignored. We will touch on how to get, well, how the error messages work when we write the script a little bit later. So the next command we're going to be running is similar. So we're just going to run netcat with verbose mode just on port 22 because it's the only one that's open. So we're going to run it like that. And you'll see, Control C to get with that, it responds with a banner. This is commonly known as banner grabbing. Essentially, what this is the banner here. What this banner means, it tells us a good bit of information. An example of some of the information that we can gather from this output specifically is SSH 2.0, so we know it speaks SSH2. It's being hosted by an open SSH server, version 9.2 P1, and on a Debian machine as well. So banners basically just return information. It's kind of like an Nmap scan, but a little bit quicker. So that, yeah, we can get useful information like this on specific ports or several ports. Okay, so what we're next going to do is we're going to create a new file called ips.txt. If you'll remember from module 3, Nano also creates files if they don't exist already, alongside opening the text editor. And we're going to put a couple IP addresses in here. First one we're going to do is 127.0.0.1. This is the loopback address. This is the localhost address. This is us. The next one we're going to put is 8.8.8.8. That's Google's public DNS. And the last one we're going to be doing is 1.1.1.1. Cloudflare, public DNS. These are all public DNSs that we can use for scanning and stuff like that, so it's totally fine. We're going to save that file, and I'm going to come out of that for now. We are then going to create a new file called, well, we're going to be building a little scanner, a little port scanner, so we'll call it prt scanner.sh, and then we're going to give ourselves executable rights to that file as well. Okay, so we always begin scripts by shebangs. So we know a shebang finds the interpreter that the system's going to use, telling the system we're going to use bash for the script. We know this is clockwork now. So we're going to come down 2 lines and we're going to create a new variable called timestamp. And this timestamp variable is just going to hold the date. So just like that. And now we have the date stored under the timestamp variable. I'm going to come down again and we're going to create a file name variable. So basically, we're going to use the timestamp and put it into the file name. So make sure this is in quotes because it's a string. And we're going to put scan results. And then we're going to come down. Sorry, not come down. Sorry. We're going to put the timestamp variable in here and then just txt. So what this does is we are substituting the result of the date into the scan results name. So basically, when we create these files, we get different names that include the date the scan was taken. Very useful. You could either put the date inside the file when you're making this in like a real scenario, or you could make it easy and just put it in the name. Then people know, this is the scan taken for this day before they even look into the file. So nice. We're going to come down again and we're going to create a for loop that loops over the IPs that are in ips.txt. So we know that cat empties the contents of a file, so substituting in like this basically means we're going line by line. So we're going through so we're going to be executing this command for each line in ips.txt essentially. So come across again and we're going to netcat -zv, and then we're going to put our target in here. In this case, our target is the IP addresses inside ips.txt. So how do we target them? We use the IP variable. So we've already, we set IPs here. Okay, so for IP in each of these IPs that are going to be listed line by line. So in netcat -v for each of these IPs in that line as we're looping over them. This is what a for loop does. And then we're going to specify the ports that we want to target as well. We know for our own machine that port 22 is open. We know that port 80 and 443 is closed. However, for other domains, the other IP addresses that we will be scanning, they may be open. It will be almost certain that those ports are not the same as ours, and SSH probably won't be open for any of them. Anyway, so we're going to make 2 greater than symbols, basically to append the results of this command into the file name. So as we know, it's a new variable, so it is encased in quotations, and normally we'd put 1 greater than symbol. 1 greater than symbol overwrites the file, but we are instead here going to append the results to the file. And then it's necessary here, this won't work otherwise, I'll explain why in a minute. You need to put 2 greater than symbol, then and 1. What this does is it sends the errors to the same file. Without this, it wouldn't work. Netcat would run in the terminal, and it wouldn't send any results to the designated file that we want to send it to without this here. This is because netcat classifies, well, it sends its results to standard error. So basically, when we run netcat, the results that we get from running that command are classified as errors, not output. So in a normal sense, where we'll be running a normal command such as nmap, we don't need to put this here because nmap's results are classified as an output, but because it's classified as an error, we need to state here that we want to send all errors to this file as well. But there is no errors. The errors are the output. It's a bit confusing, and it's all written up on my GitHub if you want to take your time reading through it. I do really recommend that you do. And we're going to come down and we are simply going to close this for loop. It's as simple as that. And then we'll come down again, we'll just say like scan saved in, and then we'll substitute the file name in here as well. Simple. So we have everything done already. Cool. We have a simple for loop that scans each of these ports, stores them in the file, stores all error messages as well, which the error messages when running netcat are the standard output messages. essentially. So cool, simple as that. That is a port scanner done just like that. So let's run it and we'll see the results. Hopefully no errors. Okay, cool. So this is going to take a little minute to run. I'll get back to you when it's finished. Take a little while for you as well, so hang tight. Okay, cool. So we can see the results have been saved. So we can list and we can see the new text file. So we can come down. Sorry, I had a little glitch going on. Don't know what happened there. Couldn't interact with my terminal for some reason. Copy the file name, paste it, and examine the results. Simple as that. Port scanner done. Pish posh. Check the GitHub if you're struggling. And yeah, thanks so much for your time. I hope you learned something. And yeah, cool. Awesome.